Hi, Fortitude Labs and ISI Kolkata. Thank you for giving us the opportunity to present our solution to this fabulous question of zero-K knowledge proof. My name is Krishan Roy, and this is OmniZKP. So let me just start by saying that the biggest problem in this ZKP architecture environment is garbage in, garbage out problem. What that means is essentially the user can spoof the data using their malicious software or encoded factory permissions or root level directory access. All right. So we don't want that. So what my core or what our team's core engineering solution is, this is hardware attestation, as well as few more interesting innovation points that I have included in this project and demo. And I'm going to show you all that. All right. Stick with me. So first, I'm going to initialize the enclave, the identity enclave. And how I'm going to do this is the Vercel hosted website, and I basically am hosting this entire demo already on Vercel. This is properly live, and in the I will link to the GitHub as well for this. So I'm going to initialize the enclave. Once the and I have clicked on that button, basically my identity has been generated instantly, essentially. And once the identity has been generated, I'm going to cryptographically bind a ZK email. How I'm going to do that is using this upload file option here. I'm going to upload a GitHub email. I'm going to explain soon what the usage of that all that will be. And once that is done, the email will be the master commit will never leave my system, and there will be recovery shards, three recovery shards exactly. I'm for demo purposes showing this recovery shards here right now. Of course, the actual system won't have them. They will be shared over the Galileu's field using Shami shared secret technology over 2 to the power 8 Galileu's field, and there will be a hard-coded AES to encryption along with a human input. I'm going to explain why I'm using human input very soon. Now, my core technology here. That is, let me come to this proof system. I'm going to generate the proof and watch what happens if I run this proof without a hardware signature. See, it failed. So what that means is the user can never generate their proof for any verifier, that is suppose this bank or the insurance or the doesn't matter, without the hardware attestation. Now, for why the hardware attestation is mandatory or essential is, suppose the bank is asking for the user to suppose stay in that area. Okay, like you are booking tickets for a ticket platform by ensure using some services from the bank on that branch specifically. Let's suppose the Jadavpur branch. The post office on Jadavpur branch is using something providing some services that only request is only for the users at the Jadavpur area. So they are going to use the Oracle, let's say the mobile towers or anything like that. And since the mobile data or any PC data can be spoofed easily, the hardware proof is going to be generated by our own native app, the Rust app. For the demo purposes, I have provided a hard-coded hash, but in real production level, there's going to be a real attestating app, and that app will generate a attestation of these Oracle data. And once I have these Oracle data, I can generate and submit the proof. Sorry, I could have done that. Let me just turn that on there. And see, the proof has been validated. If I broke the constraint, any constraint, let's say I broke this distance constraint, it will fail as well. This is showing that the proof is obviously not working as per the required verifier mandatory criteria. Now, once I have the proof, I'm going to show you one thing, that because I have made this code in Rust with Hello Circuit technology, the proof is being generated almost instantly, almost. All right, this is showing 0 millisecond because basically there's like few nanoseconds of a difference being generated. All right, nothing is instant. So this is being nanosecond. I am not even being able to show it here. This will probably go to like max to max 2 ms, 3 ms. All right, for your use purposes. Now, once I have this, this is my W3C verifiable credential. The what this is going to do is this user can now use this to generate their proof in anywhere, any system. All right. Now I'm going to also show you that what this does. Encapsulate true to the polygon. What I'm doing here is the verifier can provide their own wallet and have this proof be existent and immutable in their polygon chain, their blockchain essentially. Now, this proof can never be changed. This is a immutable proof now, and this proof is not like leaking the data where the user is. It's just saying yes, the user is here, and it can never be changed. That's it. That's all there is. Now, what these email did is, for let's suppose the governments are like usually backlogged in verification system, right? So what this DKM does is, this allows the user to verify that they are already part of an institution. Suppose they're a developer, GitHub email. Suppose they are part of a student institution, educational institute. They have a student email or teacher email, but or they are a Googler. They have a Google email, like that. So we are saying that, see, this user already has a verified email. I'm showing you that my Rust code can parse that data and find that email header, the RSS signature, and tell you that yes, this user is verified by their institution already. So why not use that data to verify your proof, so it will be faster than making a custom government data proof. uh, or you could use that on top of that for your purposes. For here, I'm using it on this Eco Insurance Company, and it is asking for this DKM attestation. If I did not have this attestation, you will see that it showed this option, that upload a DKM signal. It will indeed fail. I'm going to turn on the TE and try showing you this here. Just a moment. And see, I told you the latency proof will be max to max like 2-3 milliseconds. This time it was 1 millisecond. And see, I did not have the DKM attestation. All right. Now, the final one is, I told you that there is going to be the Shamit secret. All right. What the Shamit secret does is, the Shamit secret is essentially the hard-coded pin I have provided here. Now, it could be anything. For right now, the pin is 4242. And now I have this. The AES 250 256 GCM encryption is basically encrypting the shards, because the shards should not be leaked. And then the encryption is being decrypted using this code, the 4242 hard-coded pin. Now the hard-coded pin could be anything. All right, the hard-coded pin could be suppose mm, the finger biometric data or anything, facial data, anything. Also, there could be solidity contracts here, more hardcore solidity contracts. Suppose, let's say, automatic in configurations that the user has been inactive for 2 years. Now only the Guardian recovery system will work, all that stuff. All right. I have made a Rust coded testing system so that tests if everything is working correctly or not. And anything else I have to say is, oh, also one more thing is that I have provided the post-quantum PQC mode. What that is, what that does is, suppose the quantum technology comes and Shor's algorithm breaks every like hello to architecture or anything like that. What this does is, if there is a situation of that arising in future, that the quantum technology has improved, you could hot swap the hello circuit using the post quantum code or the mathematics. Just easily just put that mathematics here, PQC struct, and just click this on or in code, it will work absolutely fine. This is just that it's showing, I'm showing you that it could be hot swappable. All right. So yeah, that's about it. And let me summarize the innovations I have here, that it is complete, it's sound, it's zero knowledge, and unlinkability, because these two proofs are not at all linkable. So they cannot like change their or exchange their database to find about the user, profile their user data. These are the mathematics. To talk about the mathematics, I have to go a little bit in depth. That is the essentially what I'm doing here is, let's say the user is at a distance of like 100 meters, 200 meters, 300 meters, whatever the verifier requires. Okay. So I have achieved a complete O1, that is a constant time of O1, using this algorithm, that is this. What this does is, if the user is outside the geofence, the gate evaluates to a non-zero element, and once that is non-zero element, the permutation argument shatters, completely shatters instantly. All right. But if the user is in a valid space, the valid physical is considered a discrete root. That is this one. This it will be getting to. It will just essentially make this complete zero, and that will make the polynomial zero. And yeah, that's about it. We are going to fix that issue. This is my architecture here, and These are my summarized innovations that I have completely made the shard recovery MPC, the O1 system, and the cross-chain state anchoring. All right. Thank you. And if you have any questions, please go ahead and email me or ask me. I have the code open source as well as the GitHub and Vercel host up live. Thank you.